Debug hard. Let's write a test with the basic assertion. We're looking for a welcome to nyc.rb message. So we run this test and it blows up a few times actually until you have this piece of code with the welcome message. We run the same test again and it passes. Life is good again. My name is Vishal Chandani and I wrote this test at Def Method in New York City. How's that for a test-driven introduction?
Very nice.
So honestly, I had the idea of the test-driven introduction long before the talk. Way too much spare time on the train to NYC. Some personal inspiration. My best friend of 15 years, actually 16 this year, and two little gems of our own. Quick disclaimer, get that out of the way. Every talk needs a good story. As a relatively new Ruby developer, I was fascinated that Ruby is written almost entirely in C. And after a few years, I started noticing the method implementations in the documentation, where you click on view source. And at Def Method, I actually presented some Lightning talks to compare Ruby versus C programs. And as I dived closer into the implementation of the reverse function in the string library, I realized that certain strings don't play well with certain methods. In other words, Unicode strings with the reverse method. And so my first instinct was, there's something wrong in the implementation. So I put on my debugger hat and decided to venture down the Ruby source code and decided to find my very first bug in Ruby. And of course, some investigation, several days later, I realized that the reverse method was actually doing the right thing, but Ruby was incorrectly representing certain types of strings, for example, Unicode characters. And so I took a step back and put together this talk to show a more logical approach to debugging such types of problems. This is a picture of the actual moth, which was found trapped in a relay of a Mark II computer at Harvard University in 1947. Meet Admiral Grace Hopper, the woman behind that Mark II computer at Harvard University. In a few interviews, she admitted that she wasn't coining the term debug, but honestly admitted that she made the term popular for us. I've always been fascinated that Ruby is written in C. For today's talk, we're going to look at the reverse method, which is part of the Ruby string library. C was developed in the early 70s by a gentleman named Dennis Ritchie and was originally meant to run utilities in Unix, but later became so popular by the late 70s it was used to rewrite the entire kernel of the Unix operating system. So imagine a language so powerful you can not only write other languages but also rewrite parts of an OS, which I think is really cool. I needed an environment where I could build Ruby from source, modify it, compile it, and rerun it. So I happened to choose VirtualBox, well, because it was free at the time and worked pretty well right out of the box. The talk is based on Ruby 2.5.1, which I realize is an older version, but as you'll see in the talk, some of the concepts and the principles are still valuable and applicable to newer versions. I find it fascinating that two of my favorite languages actually come together in this one file. This is actually part of the Ruby source code. The very first tool I'm going to pull out is called grep. Grep is used to search for patterns among a list of files. The actual string reverse function is called rbstr reverse. And so in order to find where it lives, you use grep minus r for recursive and search the entire tree of code to find that it lives in a file called string.c. Grep was written by Ken Thompson in 1974, and he actually wrote it overnight to help someone analyze the contents of the Federalist Papers at that time. Speaking of overnight and train rides to New York City, around the same time came this 1974 classic. So, for all you movie fans out there, this is a must see. And there are no spoilers in this talk. You have to watch this one. Being a test driven developer, I went looking for tests for the reverse method and didn't really find that many. As you'll see here, there's one test with a few assertions. It was impressive that they use unit test or test unit, but there weren't enough tests, I feel, to accommodate the different types of characters. At a high level, the rbstr reverse function, which is implemented in C, uses pointers to reverse the string in place by traversing it. The download Ruby from source website or link on the website basically says all you have to do is three steps. There's a config step, a make step, and an install step. I wrestled all weekend and a few days later had a compiled version of Ruby running on my machine in a VirtualBox instance. So I set out to write a simple Ruby program that I called debugger.rb and used this string as the exercise for reversals. Raphael, the little lowercase e with the two dots, as I used to call them when I first learned them, is really the diathesis. The two dots is the diathesis symbol, and it's used to indicate the letter that you emphasize, even when you say the full name. So normally you would say Raphael. In this case, you would have to emphasize it again. Other examples include the word re-entry and the name Chloe. Meet Rafael Javier Varane. He is one of few people who spells his name with diathesis. So, fun fact, he actually plays football for Spanish club Real Madrid and the France national team. And I told my buddies at Emirates I would say this. This part of the talk is brought to you by Emirates. Thank you. Using his name as an example and running it through that simple debugger.rb, where I have a string called Raphael and run str.reverse, this is what we get. So as you can see, the two dots are on the wrong letter. So what really happened? Let's take a closer look. The second tool is actually we're still in Ruby domain, or actually we're moving from Unix to Ruby domain now. Previously, grep is provided in Unix. Chars is a Ruby method that you can run on a string. As the name suggests, it splits the string into a set of characters. This is where we see the letter E with the diathesis gets split into two characters. The E followed by something called the combining diathesis. At this point, we need to understand a little bit more about Unicode. So in simple terms, Unicode is a standard that allows you to encode, represent, and handle characters in different formats and different languages. In other words, characters that you can't simply type on a keyboard. Here's an example. This is the Devanagari Om. I think something my Asian friends will recognize. That's represented in Unicode. It has its own sets of bytes as sequence. And in the latest standard of Unicode in 2019, the version 12 actually supports over 137,000 characters in a variety of languages. At a high level, Encoding is in UTF-8, UTF-16, and UTF-32 formats, which basically use 1 byte, 2 byte, and 4 bytes to represent the characters in their allocated space. The idea of Unicode was proposed by a gentleman named Joe Becker at Xerox in 1988, where he proposed Unicode as a unique, universal encoding scheme. Around that same time came the inspiration of the title for my talk, and happens to be one of my favorite movies, 1988. The third method in our list of tools is something called code points. Code points, oversimplified, is basically a numerical value of a character in its encoded space. And again, you run it on a string, loop through and display each character as is and a string value. So here the letter E is represented by hex 65, followed by the combining dialysis, which has a hex representation of 308. The next method actually is one of my more favorite methods because it's diving down yet one level lower, closer to the byte level, which is important because that's where the implementation of C operates, at the byte level. Same idea, loop through the Raphael string, display each byte. We see that the letter E is represented by hex 65, and the combining dialysis have hex CC and hex 88 respectively. Before we dive into the implementation of the C reverse function, let's take a step back and understand the idea of pointers. Pointers are a C concept, and as the name suggests, they point to other variables in memory. So knowing the address of a given variable in memory allows us to read the contents of that address as well as write to that memory location. Powerful, a little dangerous at times, but extremely powerful if you know what you're doing. Again, pointers come in different shapes and sizes, a scene that is very popular in many kids' schools, pre-pandemic, of course. Here's a simple example that shows a string called hello world, 25 characters, up to 25 characters, and we declare a pointer variable called ptr, use that to loop through the contents of str. So we start by initializing ptr to the first location in memory at str, which is the letter H, and you loop through each character at a time until or while the contents are not \0. The \0 is very important because that's how you terminate strings in C. If you don't do them properly, you go out of bounds. So this simple for loop shows how you can use a pointer to traverse through the contents of a string one character at a time. The next tool, again, is in C territory, printf, which stands for formatted print. Very powerful, simple to use as follows. You can display a string of your choice. In this case, I'm using it to display a variable called length and precede that by a colon. So you'll see length colon the number. We now zoom in on this particular block of code in rbstr reverse, where we want to display the length of what's returned by the rbenc fast mbc length function, which is a rabbit hole in itself, but we want to start here. So we've been able to modify the code earlier because we've downloaded Ruby and built and installed from source. I then set out to put printfs in these C files, recompile them, and rerun them. Printf has its origins in BCPL's writef function and was implemented in 1966. Fun fact, that same year, here's a picture of the Whitney Museum of Art, actually their former home way until 2014 in Madison Avenue, New York City. Printf is great for basic entry and exit points of a function. But if you want to traverse a more deeper rabbit hole, like we saw the RBC ENC fast len, if you want to traverse down those rabbit holes, you can actually do that by something a little more powerful. GDB stands for GNU Project Debugger and can be used as follows. They have something called a breakpoint, which is basically you pause execution on a given file at a given line number and then run your debugger program. So here we say GDB space Ruby. We set a breakpoint, a stop point on string.c at line 5575, which we know because we now have access to the source code, and then run debugger.rb, which is the reversal code, which is the Ruby reversal code. And S stands for step through the execution. You do this a few times and set multiple breakpoints. I now have another one at regenc.c, line 62. GDB was written by Richard Stallman, 1986. Around that same time, the USS Intrepid, which some of you may have seen in the Air and Space Museum in New York City, was declared a national hallmark that same year. The function that calculates the length of the character, the encoded character, is MBC ENC len. Using the same clen printf from before, we see clearly that the letter E towards the bottom half of the slide has a value of 101 space 65 and a length of 1. The combining diathesis somehow doesn't display properly in C, but it shows a length of 2 bytes. So the E with diathesis we saw visually on the screen is split into the lowercase e followed by the combining diathesis and have lengths of 1 and 2 respectively. This is where the knowledge of pointers is particularly important. I was convinced that the correct way to represent E with the 2 dots or diathesis is in UTF-8 is hex C3 and hex AB and not what we were doing earlier. So I added this hack of code where if the character happens to be a lowercase e, I replace it with what I believe the correct hex representation should be for E with diathesis. And that's hex C3, hex AB for those two. Again, 2 bytes, not 1 plus 2. Then you put the lowercase l for Raphael and terminate the string with the \0. And you're done. Using that hack, you'll see down below towards the tail end, 4th line from the bottom, the word hack, we see that the length of this new character is 2 bytes, as we expected. You pass that again to the reverse method, and voila, we now have a correctly reversed string with the diathesis in the right spot. I don't like seeing my favorite uh, programming languages go to war. And at this point, I was convinced that there's no bug in the underlying C implementation. And we've confirmed that Ruby is incorrectly representing certain characters by splitting them up in sort of unexpected ways. So I guess movie trivia time. Anybody recognize this famous arm wrestle scene?
Predator.
Hey, there we go.
No, it's not. It's not. It's not an arm wrestling. It's a handshake.
Actually, you're right. It's an
Yeah, it is not.
introduction. It's an air handshake that turns into a wrestle, right? Without the surface. Yeah, yeah.
No, it's just a handshake.
It's just
Like that's
that's
actually.
how.
Well, actually, just go back to Die Hard. There's a connection between this movie and Die Hard.
Yes, I thank you. We'll let somebody else take that question. That was going to be in my next question. What is the common element between this picture and Die Hard? And if not, if no one knows, Andrew will let you take it.
What is this movie again, please?
This is from Predator. And there's one common element between this one and Die Hard.
Why don't you give him a hint?
Actually, like if I give them a hint, I think I might give away the answer. You go ahead. You give them the hint.
Well, actually, I think the hint will be the answer too.
The hint will be the answer. Yeah, it's too. It's
Yeah.
pretty straightforward. All right, go ahead, Andrew.
Yeah, it's the director. Those
John
who were done.
McTiernan.
Yeah.
Great. We got some true movie fans in the house. Great. Let's move on. Thanks, Andrew. So when I first learned of this problem, that there are certain Unicode strings that don't play well with certain Ruby methods, like we demonstrated, I learned that there exists a solution for this problem. And people said, "Hey, just use Unicode normalize." So I said, "Okay, let's dive into it, see what it means, see how it works." So Unicode and the idea of normalizing introduced some new concepts. There's the idea of equivalence, whereby certain sequences of bytes essentially they may be different, but they essentially represent the same character that we see visually. Like one example was the letter E with that diathesis has a representation, but you can also make that using the lowercase e itself and then combining it with the diathesis. So they may look the same, but their underlying representations are different. And normalizing allows you to basically go back and forth where you can convert characters that essentially look the same using the same set of byte sequences. Here are some examples. Canonical composition is the idea of actually combining the two. So the lowercase e followed by Unicode 0308 gives you the e with diathesis with the size of 1. Decomposition works the other way around. You take what you had earlier and use the NFD form to decompose it and split it into 2. So the e with diathesis becomes e followed by the combining diathesis and has a length of 2. We now use Unicode normalize and use the same set of tools in our tool belt, right? We have the chars, code points, etc., and do a before and after comparison. So on the left is something we've already seen before without Unicode normalize. And on your right, you have the after Unicode normalize. So in this case, chars correctly shows the E with diathesis as intact. In other words, it didn't get split into 2. Code points, where we previously had 101 and 776, now show us decimal 235. Going to my favorite method, each byte, where we previously had hex 65, hex CC, and hex 88 on the left, we now have hex 63, hex C3, and hex AB as the correct UTF-8 representations of the E with diathesis. At this point, I felt like I had enough material for the talk because we had a known problem. We were able to explain the problem. We then learned that there's a Unicode normalize method that you can use to work around the problem, and we can see how this works. So I started diving a little bit deeper into the implementation of Unicode normalize, which lives in this file, normalize.rb. The default form of normalization is NFC. So I zoomed into just that block of code where you see the G sub, regex underscore C with NF hash underscore C. So in simple terms, it's basically looking for the character in a hash called regex underscore C and then replacing it based on the key in NF hash underscore C. And again, to better understand this, I added some debugging variables, M1 and M2, where M1 is essentially the string or what you want to match on, in this case, the E with diathesis. So chars, code points, each bytes, all that stays the same. M2 on the right is the hash value that you want to replace it with. So while they look exactly the same on line 2, their Char's code points and each byte representation is very different. And so we see we have the E with diathesis correctly represented as hex C3 and hex AB. Using that Unicode normalize in place before doing the reversal, we started with a string like this, Raphael, and ended up with a correctly reversed string where the diathesis stay intact. And we have two ways to do this. We have the Unicode normalized way to do it. We also have an internal hack to show why it happens in the first place. Along the way, we learned some basic Unix, Ruby, and C language tools. And may seem really straightforward. There's only 6 tools here, but combined carefully actually give you a better insight into such problems where you may have a problem that appears to be at the surface, or as you may suspect, is underneath the surface and you need to dive into the implementations. So combining these, hopefully this talk inspires you to debug hard and to keep investigating problems not only at the surface or not only in the implementation, and not making any assumptions like I did. I instinctively assumed that if a language is built on top of another one, the fault lies underneath. Well, that's not always true. So it's better to have an open mind and approach it, more holistically. You have been a fantastic audience. Namaste.